My name is Dr. Sunghamindira Devi. I'll be teaching chemistry for class 11 and 12. Hello everyone. Today, from chemistry, we'll learn Unit 4, Chemical Kinetics. The main objectives of this unit are to define the average and instantaneous rate of a reaction, to express the rate of a reaction in terms of change of concentration of either of the reactants or products with time, to distinguish between elementary and complex reactions, to differentiate between the molecularity and order of a reaction, to define rate constant, to discuss the dependence of rate of reactions on concentration, temperature and catalyst, to derive integrated rate equation for zero and first order reaction, to determine the rate constants for zeroth and first order reactions, to describe collision theory. Now, let's try to understand meaning and concept of chemical kinetics. ꯑꯩꯈꯣꯏꯅ ꯈꯪꯉꯤ ꯃꯗꯨꯗꯤ chemistry ꯍꯥꯏꯕꯁꯦ ꯃꯍꯧꯁꯥꯅ ꯁꯦꯟꯁ ꯑꯃꯒ ꯑꯗꯨꯃꯛ ꯂꯣꯏꯅꯅꯤ. ꯀꯔꯤꯒꯨꯝꯕ ꯁꯦꯟꯁ ꯑꯁꯤ physical sense ꯑꯣꯏꯕ ꯌꯥꯏ, chemical sense ꯑꯣꯏꯕ ꯌꯥꯏ. ꯍꯥꯏꯔꯤꯕ sense ꯑꯁꯤ ꯃꯇꯝ ꯄꯨꯝꯅꯃꯛꯇ with respect to time associate ꯇꯧꯒꯅꯤ. ꯍꯥꯏꯔꯤꯕ with respect to time associate ꯇꯧꯕꯁꯤꯗ reaction khara amadi fast oiba yai, khara amadi slow oiba yai. Let's see how fast the reactions are and the slow reactions are. Fast reactions are those reactions that complete in a very short time, such as less than 10 to the power minus 6 seconds. For example, precipitation reaction, burning of magnesium ribbon, neutralization between acid and a base, lightning, slow reaction, chemical reactions that occur very slowly and take a long time for completion are called slow reactions. Example, rusting of iron, fermentation of sugar into ethanol, curdling of milk, Masinataba, atopa, yamna kuina sangba, asukimate kuina sangba sulay, kanano habida, yamna kuina matam sangba, reaction karadi, decay of carbon 14. Carbon 14 chi gram amakak tang haida reduce towa. Haibadi wakaina half lifetime hana kangnay. Carbon 14 ki half lifetime asi asukimatic sangre karino habida 5,730 years oiniva. Aduna reaction asi reaction ki matungina very fast oiba, slow oiba, very slow oiba reaction hana kangnayeva. Now let's try to understand about the chemical kinetics. The branch of chemistry which deals with the study of reaction rates and their mechanisms is called chemical kinetics. Chemical kinetics da khoina naina doisi reaction kyam fast oiba, reaction kyam slow oiba se masida khoi hojik in detail naina rani. The word kinetics masi karya di lakono haibda Greek word gi thaidarak pawari ni. The word kinetics haibasi Greek word kinesis haibadi movement haiba adudagi thangdarak pani. Then akhoi hoji chemical kinetics haibasina kari kana gi haibada it not only to describe or determine the speed of a chemical reaction, but also it describes the conditions by which reaction rates can be altered. Karma condition, concentration, temperature, pressure, catalyst, asina chungba singsibu aikhoina nainabada chemical kinetics ki yana chauraba mathau lei. Now, aikhoi chemical kinetics ama leinaba matamda rate of a chemical reaction, rate constant ki role yana chawi. Rate of the chemical reaction asi kamaina khangadagi haba amuk yengsi. The rate of a chemical reaction can be defined as the change in concentration of a reactant or product per unit time. Any reaction am sathabada ikoi reactant habam sutare, product am habam sutare. With respect to time kaidoni concentration of reactant se sum handarakani ba. Reactant na sum handarakani aduga concentration of product na sum hengalakani ba. Asiguma tamsida akoina reaction rate haibase with respect to reactant, with respect to product akoi tunga nainarakani ba. Atopa amada akoina rate of the reaction si kamaina su define tawu yai. It may also be defined as the amount of the reactant that has been reacted per unit time or amount of the product that formed in 1 unit of time haineba. Masigi representation akoi sida pire rate of the reaction or reaction rate is the ratio of the change in molar concentration of the products of or reactants open time taken for the change haineba. Masige akhona mathematical expression irakpa matamda square bracket ama mafamsida oliba square bracket si aduki mate sijinar masina kari signify tauge haibada molar concentration of a specific reactant or specific product amagi molar concentration signify taunieba mafamsida akhona piri concentration of A sida piri symbol sina tai basi molar concentration of species A gi ta A haba akhona adu ardi hoji rate of the reaction gi unit to karino amuk khangnaba yengsi akhona khangre madudi rate haibase concentration per unit time ni adu ardi concentration je akhona karigumba moles per liter da unit chi oiraga time sina karigumba seconds to oiraga di rate ki unit se kari hoiba tare moles per liter per second oirni hoji akhoi average rate of a reaction amuk khanasi. Let's consider a general reaction R to give P. Akhoi na mafam sida R sina reactant ni P na product ni. Maram aduna akhoi mafam sida concentration of reactant R, concentration of the product P at any time T1 mafam sida represent tawduna P re. Aduga loina na concentration of the reactant R and the concentration of the product P at any instant of time T2 haiba ma P re. Asigumba time ani T1 and T2 haina longna ba matam sida T1 and T2 si aikoina puthoke hairaga di sense of time si kamaina pigani magi symbolic representation ni mafam sida pi se capital delta T natraga dt masi aikoina sense of time gi representation ni masi ki difference T2 minus T1 ji oini ba karam matam da if T2 is greater than T1 T2 na T1 dagi helagadi sense of time se asumna piganieba. Similarly, for sense of concentration of the reactant and the sense of concentration of the product is also given here. Masi khanga matungda aikoina rate of R yengagadi rate si aikoina khange reactant se with respect to time asumak diminish torakani decrease torakani eba madubo aikoina rate with respect to R haibasu yai natraga rate of disappearance of R haina khangnani masigi representation mafam sida pire decrease in concentration of R with respect to the sense of time mafam sida pire adugi matungda amu with respect to product amu gengasi rate of appearance of product masi haribe maramdi karino haibada with respect to time product ki concentration ji sum hengalakani ba product sum appear torakani masi su khoina kamai pire masi gi rate che sense of concentration of the product P with respect to the sense of time mafam sida represent tawduna pire aikoina expression ani sida negative haiba ma positive haiba ma sign convention ani ubo phangi masi it is only a sign convention ni negative sign indicates that it decreases in the concentration level and the positive sign indicates increase in concentration of the product with respect to time. Now let's see rate of reactions for some common reactions. Ahanbagi si decomposition of hydrogen iodide chi kanada hydrogen and iodine decompose tawre mafam sida khoina ure 2 moles of hydrogen iodide na 1 mole of hydrogen ga 1 mole of iodine ga decompose tawreba asiguma matam da khoi rate of reaction masigi piba taragadi masigi expression je mafam sida piri sense of concentration of hydrogen iodide upon sense of time masida piri makhada piri ba 2 na divide tawri bisi karigino 2 na divide tawri maram di karigino haibada this 2 moles of fraction ji ne 1 mole do eragadi asumna p ne 2 moles se this is only the stoichiometric coefficient from the rate of the reaction and the sign also given here negative sign with respect to decrease in the concentration of hydrogen iodide. And then for hydrogen it is given here sense of concentration with respect to hydrogen upon time sense of time P and also for iodine it is also given here. So you already know the sign conventions regarding hydrogen iodide, hydrogen and iodine. Next, let's have a look at the second relation. The second equation is formation of ammonia from nitrogen and hydrogen. ꯃꯐꯝꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯎꯕ ꯐꯪꯉꯤ 1 mole of nitrogen gas ka 3 moles of hydrogen gas ka react tawraga 2 moles of ammonia gas phangi hariba reaction asigi rate of equation su piri kanaga sense with respect to concentration of nitrogen, sense with respect to concentration of hydrogen, and sense with respect to concentration of ammonia mafam sida piri akoina uri sign convention da nitrogen ga hydrogen ga da negative sign yauribasina indicate tawi decrease of concentration with respect to time, and positive in ammonia sina kai high increase in the concentration of ammonia. Now let's try to calculate a problem. Hoji akhoi problem ama hona be yengsi for the reaction nitrogen pentoxide gas na decompose tawi kanada nitrogen dioxide and oxygen da Masi matamda the value of rate of appearance of nitrogen dioxide is given as 6.25 into 10 to the power minus 3 moles per liter per second. So your question is calculate the rate of formation of nitrogen dioxide and oxygen. Akoina mamang khot ki ba dumaina hai riba equation sigi rate of reaction ithoani ithoe mafam sida rate of reaction sidagi aikoina amu rearrange tawra kari taw phangni asai nitrogen dioxide ki putho hairaga di akoi nitrogen pentoxide ki pirabanina nitrogen dioxide ka nitrogen pentoxide ka ani sigi comparison tawni adu aidi akoi kari phange rate of appearance of nitrogen dioxide si kya phange 2 times of rate of disappearance of nitrogen pentoxide ka manani eba adu aidi 2 into 6.25 into 10 to the power minus 3 mole per liter per second koi kya phange 1.25 into 10 to the power minus 4 moles per liter per second. Similarly akoina amuk sumaina rate of formation of oxygen gi su sai nitrogen pentoxide gi 2 na divide tora kya phange 6.25 into 10 to the power minus 3 divided by 2 equals 3.12 10 to the power minus 3 mole per liter per second. Asumna aikoina rate of formation khangaba natraga rate of appearance natraga rate of disappearance data ama khangagadi atopa data amada ilai line hotpa ngamgani. Now let's see what an instantaneous rate of reaction is. Aikoi mamang da average rate of the reaction hot khare karigumba reaction amasi overall reaction amagi amukta da rate of the reaction hot pa haibase accurate oigande hot pa yae no koi hot khraga su masi accurate oiba wali adu oraga di aikoi instantaneous reaction na yam apikpa reaction si yam apikpa smallest interval of time pina khaiduoga holaga di madu boy khoina kaidoge instantaneous rate of the reaction calculation neba adadi let's see what an instantaneous rate of reaction is. Instantaneous rate of reaction is defined as the average reaction rate at the smallest interval of time, that is when change in time approaches to 0 time give change interval ji am pihalagadi adu oragadi aikoina overall reaction amada macha mayam ama khaidoga instantaneous rate of reaction mayam ama su thokpa yaiba. Instantaneous rate of reaction ki graphical representation su mafam sida piri aikoi hoji rate of the reaction si karam ba factor gi makha pon ga mukhana si ahan bade koi nature of reactants si reaction ama complete oina bagadi yamna maru oiba khangdaba yadaba mani aikoina reactant sing sida substance sing sida polar ionic non ionic haina mayam ama leini aikoina amu khangadabadi reactions involving polar and ionic substances are usually very fast. Reactions involving electron transfer reactions, oxidation reduction reactions are slow as compared to ionic reaction. Asumaina aikoina ionic kumba polar kumba reactant oiragadi reaction se aduki matik fast oi kana yenor matamda oxidation reduction oigera natraga non ionic non polar oigera adugumba dagedi ionic ni hena fast oi maram aduna aikoina reactant khanbada natural reactant jisu yam maru oi. Another factor is temperature. Generally, ekhona khangi madudi the rate of the reaction increases with increasing temperature. Rate of the reaction se generally increase torani. Adu masi ekhoi endothermic oiba exothermic oiba habigi makha de leikre li satale principal kaina ko 11 da mayam su tamkhre. Adubu kaidogi habida if the reaction is exothermic, reaction se exothermic oiragadi temperature se kaidoni temperature increase to we are oiba adu mode temperature decrease to hangani ba. Aduna we should know that in general the reaction rate increases with increasing temperature. Masi akhoi karina explain to we temperature coefficient have a factor amasu akhoi tungda hola kigani kamaina holi temperature coefficient have si karino where the reaction rate increased by a factor of 2 or 3 for every degree 10 degree rise in temperature na temperature se 10 degree hangali khudingi akhoi rate se temperature coefficient govern tawi kamaina makhoi di hangali basi 2 nataga 3 hangali have. Another factor is the concentration of the reactants. So we also know that the rate of the reaction increases with increase in the concentration of the reactants. Karigi, why? Due to increase in molecular collisions at high concentration. Now, let's go to catalyst effect. So we know what a catalyst is. A catalyst is a substance that alters the rate of the reaction without itself taking part in the reaction. Catalyst also positive catalyst, negative catalyst ana laigani. A positive catalyst increases the rate of the reaction while a negative catalyst retards the reaction. Mafam sida piriba energy profile diagram da piribasi positive catalyst amagani ekoina sida cup ani ure kauramna amana with catalyst amana without catalyst ni. Next factor is the surface area. Ekoina khangani greater is the surface area of the reactants, more is the rate of the reaction. Kamai khangani kaima substance ama je akoina powder kupna thugairaga suppose metal hairone metal thugairaga hapsan baga metal matum mama thadabaga reaction je fast oibase powder oiba makup ni heni ba maramdi karigino powder singduna lam to the surface area hen baine. Now let's have a look at elementary and complex reactions. Elementary reaction is karino step ama khakta da loisan ba reaction du bo khoi isam jamna elementary reaction kawi. Complex reaction hairagadi madugi reaction to the there are so many steps of reactions are there. Reaction macha mayam thu yauni ba asigum matam da khoi order lakhigani order kamai determine tawi order haibasi hojiki multi step to the step mayam to the khwaidi slowest step am soi gi yarangani ba slowest step to khoi rate puthok si na gini ba tung su lakhigani. Then molecularity is a complex reaction and combine determine tawi amusu lakhigani. Molecularity is determined only for this different steps. Molecularity haibasi aikoina reaction amagi as a whole puthok di yaroi ba reaction amasi complex reaction amasi akoina haire tongan step mayam amna punsilaga sembani haiba haire step macha chingdugi molecularity di puthokpa yagani adubu overall reaction dugi molecularity di puthokpa yaroi ba adubu order puthoke haragani slowest step to khalani maduna rate determining step oigani. Now let's analyze dependence of rate on concentration. Concentration ga rate ka kari mari leinage masiba khoina kari pi low mass action jina pi gani aikoina khangi madudi chemical reaction khudingmak makhagi nature natabida during their reaction process to the reactants are consumed. That means concentration of reactants are decreased whereas products are formed. Graph is only concentration graph is kari only concentration versus time curve ni mafam sida A sina uleba sina product kini B na reactant kini aduna de akhoi hoji the relationship between the rate of a chemical reaction and the concentration of the reacting species is governed by the law of mass action. Let's see law of mass action machi khoina differential rate law haina ju khangnai magi statement da kari hai at a given temperature the rate of a chemical reaction is directly proportional to the product of molar concentration of the reacting species raised to the numerical coefficients also called stoichiometric coefficient. Example let's consider a general reaction. Reaction sida reactants A and B are reactants, C and D are products. Where A and B is the stoichiometric coefficient of A and B. A na small a sina A have a reactant stoichiometric coefficient ni, small b na B have a reactant stoichiometric coefficient ni, C sina C have a product to give stoichiometric coefficient ni, D na D have a product stoichiometric coefficient ni. Rate expression for this reaction according to the law of mass action, rate is directly proportional to molar concentration of the reactants. Rate equal to K concentration of A raised to the power A and the concentration of B raised to the power B. Where K is proportionality constant and called rate constant or velocity constant or specific reaction rate. This equation, which relates the rate of reaction to concentration of reactants, is called rate law or rate expression. Rate expression has velocity constant, rate constant K unit. Now, let's try to understand order and molecularity of a reaction. Order of the reaction. The sum of powers of the concentration of the reactants in the rate law expression is called order of that chemical reaction. It is experimentally determinable. Experiment na hot kani matau karam na. Rate expression sum of the power of the concentration singdo. Madu bokena tinsin naraba matung sida kari phangi order of the reaction phangeba. Khudam ama yengsi piriba reaction sida reaction of piri reaction sida rate equation su piri hojik rate equation jiri yengsi A gi reactant A sida power kaya raise tawi A raise tawi small a B da reactant B da raise tawi power se B ni mase koi equation de yauri equation de yauba siga sida yauba rate expression sida yauba ga anisi manaba su yai manada su yai adubu for the time being hojiki hoina di mana hale matungda manada su urakigani aikoi order asi reaction si with respect to A hot pasu yai with respect to B puthok pasu yai adadi order with respect to A is A order with respect to B is B adadi for this reaction overall order of the reaction kya tare A plus B hai and so high kre order of the reaction si experimentally determined the way it may be 0, 1, 2, 3 or even a fraction. Now let's have a look at some common reactions. Hanbe reactions rate expression P. Rate expression siga equation siga amukta compare tausi. Rate expression siga equation siga compare tawu matamda rate expression da chlorine si akoi ge magi coefficient si half si yaude adubu rate ki equations ti yauri equation sina theoretical ni piriba reaction sina mafam sida piriba reaction sina theoretical ni aduga rate equation piriba sina experimental ne wa akoina hana hai kre order si experimental value ni aduna akoi reaction dagi determine taw ya deba rate expression si dagi determine taw ba rate expression si akoina ui kari ui chloroform gi oina kaya stoichiometric ratio kaya oi power kaya oi 1 oi chlorine gi kaya oi half oi adedi order of the reaction si kaya tare 1 plus half equals 3/2 oi ni ani subasi amu yengsi ani subasi akhoi yengbada order si ani lebidi mali adubu experimental demo oiramodoi ni masi pire rate expression ji matungina akhone yeng matam sida kari oige habada expression ji matungina hydrolysis of ethyl acetate ethyl acetate hydrolysis tawada ethyl acetate hydrolysis tawu matam sida akoina yengbada order si second order mali order ani lebidi mali adubu rate expression gi matung ina di masida piriba stoichiometric coefficient se power si 1 khata pi maramaduna masi khoina order si 1 haineba mathang da khoi zero order reaction natraga zeroth order reaction si karino haina khanasi a reaction is said to be a zero order reaction if it is independent of the initial concentration of the reactants. Example ma yengsi kone example ma yeng matam sida hydrochloric acid se hydrogen and chlorine degi semgalakpa matam sida hairiba rate expression sida rate asi concentration of hydrogen oigera concentration of chlorine oidra concentration of hydrogen gi natraga concentration of chlorine gi amatta makha ponde adoi di hoji kari leire aikoina leiri se rate becomes equal to k mananeba that means rate is independent of the concentration of the reactant hydrogen and chlorine haini ani suba expression sida mu yengsi machine decomposition of ammonia to form nitrogen and hydrogen ni hariba reaction asida masigi rate expression dasu amu rate se is independent of concentration of hydrogen as well as rate is independent of concentration of ammonia aduna di mase rate siga kya gong manani ki ga manani eba aduna khoni ji kari khangba yai thus in a zero order reaction the rate of a reaction is equal to rate constant of a reaction. Now let's try to understand units of rate constant. Rate constant ki unit amu yengsi mafam sida reaction ama piri general reaction ama aduna khoi rate su pam sida pire k se kamai hot kani k se ai khoi in terms of equation olagadi moles per liter per second divided by concentration of the reactant raised to the power n oineba hazik if n equal to 0 adu di kai orani it is a zero order reaction kawe zero order reaction amada unit k se kaya pire moles per liter per second pini maram di karigi it is independent of the concentration of the reactants hai giba next amu yengsi if n equal to 1 it is called a first order reaction units of k mafam sida hotle kaya tare second inverse neba or second inverse or per second if n equal to half adu de khoi kari kawe half order reaction kawe aduna magi unit si mole half liter half per second tareba sumaina n equal to 2 second order reaction third order reaction tongan hot pi ai mathang da khoi molecularity of a reaction yengsi the number of reacting species atoms ions or molecules taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Sai order siga molecularity ga mukhena ba mana molecularity haibasidi aikoi reaction du yenga ko khangani ba example am leire molecularity se kaya oige haibada ammonium nitrite si nitrogen and water gas ta decompose tawu matam sida aikoina molecularity si 1 oi haini ba maram di karigi ammonium nitrite se only 1 mole khatane ba sida sizinari se 1 mole of ammonium nitrite sina it brings about the change and decompose into nitrogen and water haini adudi molecularity 1 oi kari kawe aikoina unimolecular reaction haina kangne mathangi reaction da mu yengsi decomposition of hydrogen iodide into hydrogen and iodine mafam sida koi hydrogen iodide se magi number of moles se ani sijinai maduna koi molecularity se kai kauni bimolecular oi haini molecularity equal to 2 tani ba ahum suba reaction yengsi ahum suba reaction sida masigi reaction sida koi uba phangi madudi 2 moles of ferric chloride reacts with 1 mole of stannous chloride to give 2 moles of ferrous chloride and 1 mole of stannic chloride. Asigum matam sida amo akhoina ui kari ui molecularity si 3 oineba asumaina trimolecular oi haineba sumna unimolecular bimolecular trimolecular haina koina molecularity sibu tungan tungana mangod leiriba masing dugi matungina khangnaba yai. Now let's have a look at the distinction between order and molecularity of a reaction. Akoi yengsi sida point khara point taruk piriba point taruk sida ahan bagi yengsi. First point it is the definition as it is. Order order of reaction is the sum of the coefficients of the reacting species involved in the rate equation, whereas molecularity is the number of the reacting species involved in simultaneous collisions in an elementary or simplest reaction. And order is an experimental in nature, whereas molecularity is theoretical in nature. Order is derived from the rate equation, whereas molecularity is derived from the mechanism of reaction or course of the reaction. Order can be zero, fraction or whole number, whereas molecularity should always be a whole number. Order depends upon pressure and temperature, whereas molecularity is independent of pressure and temperature. In a multi-step reaction, order can be determined from the slowest step, whereas for molecularity in a multi-step reaction, molecularity of the overall reaction cannot be determined. Molecularity of the single steps can be determined. Hariba differentiation distinction se aina mamang su yam adumak explain tawda yawkhre aduna masi aikoina order and molecularity differentiate tawba matamda masi piriba point sing asi sizinagani. Now aikoi hojik pseudo unimolecular reaction habidi karino yengsi. Those reactions which seems to be a second order reaction but follows the kinetics of a first order reaction is called pseudo unimolecular reaction. Yengbadadi aikoi icham chamna second order manba aduga in practice, in experimental practice study first order reaction ki kinetics follow toramagadi madubo aikoina pseudo unimolecular reaction kawi. Khudam khara yengsi. Inversion of cane sugar. Mafam sida aikoina ui sucrose reacts with water to give glucose and fructose. Adubu rate expression dadi kaidoge habeda rate equal to K concentration of sugar katang pi neba. Water ki contribution yaudeba experimental da aduna masida order si 1 dareba. Yengda second order malaga su magi assembly experimental order di 1 phangeba. Similarly, hydrolysis of ether da ethyl acetate hydrolysis tawda su hariba same nature shimak phangba ngamgani ba. Now let's have a problem. A reaction is first order in A and second order in B. Write the differential rate equation. How is the rate affected on increasing the concentration of A 3 times? How is the rate affected if the concentration of both A and B are double? Akoi yengsi haiba reaction si reactant A haiba maga B haiba maga oidoni. A na first order oi, B na second order oi haiba neba. Madugi differential rate iragadi akoi stra laire K rate equal to K concentration of A concentration of B square. Sumna igani. Mathangda amuk haiba rate sida concentration of A say 3 times hengal alu haiba neba. Akoi equation pidun laire. If the concentration of A is increased 3 times, rate equal to K concentration of 3 times A into concentration of B square. That means 3 times K concentration of A concentration of B square. Masida takudi kai tai the rate will increase by 3 times. Mathang amu yengsi if the concentration of both A and B are double. Adoidi rate equals K concentration of 2 times A into concentration of 2 times B square. Sinam kaya manani this equals 4K A B square. That is the rate will increase by 4 times. Ngasi ki di akhoi order and molecularity ki matang sida ngasi ki para si loisilani. Thank you all.